Okay, so let's get started on your review sheet that is due on Thursday, May 3rd, and then for your test on Friday, May 4th. Alright, so for the first one here, we have 300 students in a high school surveyed about their favorite subject. 100 of them are sophomores, and 87 say their favorite subject is history. So the probability of them being a sophomore is 100 out of 300. Then we have 87 say that their favorite subject is history, so probability that they like history is 87 out of 300. If the probability that a randomly selected student is a sophomore that loves history, so sophomore and they love history, is 51 out of 300, what is the exact probability that they are either a sophomore or a student that loves history? So I'm looking for this. I'm looking for the or. Okay. So from here I have that long formula. So it's each individual one minus the both. Okay, so the probability of this is going to be 136 out of 300, which is equal to 34 out of 75. Number 2, 120 patrons out of that are surveyed about different types of pets that they have. So 65, so the probability of them having a dog is 65 out of 120. The probability of them having a dog or a cat is 102 out of 120. And the probability of them having both a dog and a cat is 28. What is the probability? So this is what I'm looking for, the probability that they have a cat. So I'm going to use the same formula that I just used. So we have the probability of or is equal to the probability of each individual one added together minus the probability of both. Okay, so this here, this or, we said was 102 out of 120. Probability of them having a dog is 65 out of 120. Plus, this is what I'm looking for, minus 28 out of 120. So you end up getting that the probability of them having a cat is going to be, the same I guess, 65 out of 120. But if you want to clean it up, you end up with 13 out of 24 people. Okay, so for the first one, let's just go back for a second. This was my cleanest answer, and for this one, this is my cleanest answer. Alright, for number 3, 450 elementary students are surveyed what they want to be when they grow up. 289 were female, so the probability of them being a female is 289 out of 450. Probability of them wanting to be a doctor is 104, so the probability of them being a doctor is 104 out of 450. If the probability that a student chosen at random is a female and wants to be a doctor, so and is an intersection, is 49 out of 225. What is the probability that a student wants to be a doctor if it is known? So if it is known, that's given. So doctor, given, female. So this is equal to the probability of both divided by the probability of the given. Okay, so this is equal to, both is 49 out of 225 divided by 289 out of 450. Okay, you can type that right into your calculator if you want to do the alpha y equals button. That way you get nice clean fractions, you can. And this gives me 98 out of 289. Okay, number 4. if the probability of A is 0.53 and the probability of B is 0.18, and it is known that A and B are independent. So independent events, that's when the probability of the second event has no influence from the probability of the first. So whatever happens the first time has no effect on what's going to happen the second time. So if it's known that they're independent, that means that the probability of A intersect B is equal to the probability of A times the probability of B. So I'm looking for that intersection. So here I can do 0.53 times 0.18, and I get the probability of both is equal to 0.0954. So then I can use this now to figure out what the probability is of the OR, because I have that long equation. That long equation, again, is the probability of the union. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So here, this is 0.53 plus 0.18 minus 0.0954. So I get the probability of A or B is equal to 0.6146. So for number 5, we have the probability that in February school will be open for the day is 5/7. So this is going to be the probability of being open is 5/7. The probability of snow is 3/19. And the probability that the school will be open given that it's snowing is 17/20. Determine if the two events are mutually exclusive, independent, or neither. So mutually exclusive, let's put this over here for a second. So we'll come back to the worksheet in a second. So if they're independent, that means that the probability of A and B is equal to the probability of A times the probability of B. If two things are mutually exclusive is when two events can't happen at the same time. So that means that the probability of both of them happening together is equal to 0. So either way, you need to look for this piece. You need to look for the intersection. Okay, so if we come back to our review sheet, here, this is the information that I'm given. I'm given the probability of O, the probability of S, and the probability of O given S. So I can use this formula, probability of O given S is equal to the probability of both divided by the probability of the given. So I can plug these things in order to find, this is what I'm looking for. I'm looking for this. Okay, so when I plug this in, I have 17/20 is equal to what I'm looking for divided by the probability of snow is 3/19. So I'm going to multiply both sides by 3/19. So again, you can use your alpha y equals button. So you do 3/19 and then times 17/20. So here I end up getting that the probability of O and S is equal to 51/380. So right away, because we have this tells me that it's not mutually exclusive. So to see if it's independent, I'm going to come up here because I'm running out of room. To see if it's independent, then I need to see if this here is equal to the probability of each individual one. So each individual one being multiplied together. So here this is 51 over 380. This should be equal to 5 out of 7 times 3 out of 19. So I get 51 out of 380 is equal to, here this is 15 out of 133. These two are not equal, so it's not independent, so this is actually neither. Okay. Alright. Number 6, a drawer contains 3 red clips, 4 green paper clips, and then 5 blue. 1 paper clip is taken from the drawer and then replaced. So it's put back. And then another paper clip is taken from the drawer. What is the probability that the first clip is red and that the second paper clip is blue? So if the first paper clip is red, we have 3 red ones out of 3 plus 4 plus 5 is 12 total. Then, that the second one's going to be blue, we have 5 out of, because we have this then replaced, it's still out of 12. Okay, so this gives me 15 out of 144. Right? So the second question, explain why these events are independent. So this is independent because there is replacement. You're putting it back. So whatever you pulled the first time has no effect on it because you're putting back whatever it is that you took. Number 7. A survey conducted of junior high school students found that the probability that the student regularly does their math castle learning is 0.7. So this gives me the probability. So the probability of them doing their math is 0.7. Regular does their science is 0.5. And regularly does both math and science is 0.35. So find the exact probability that a randomly selected junior does their science given that they did their math. So this is equal to the probability of both, which I have, divided by the probability of the given. So this is equal to 0.35 divided by 0.7, which is equal to 0.5. Okay, so the probability that they did their science, given that they already did their math, is 0.5, so 50%. Alright, so for number 8, determine in the example above if the two events are mutually exclusive, independent, or neither. So here, if they are, I right away know if they are mutually exclusive, because this is when, here, the probability of both would have to be equal to 0. But it's not, right? It's equal to 0.35, so it's not mutually exclusive. For them to be independent, the probability of both would be equal to each one being multiplied together. So this is times. So here, this gives me 0.35, which it is up here. So this is independent. Okay? Which you can look at here too. Think about it. If the probability that they did their science, given that they did math, is the same thing as the probability of them doing science, them doing their math has no influence on whether or not they also did their science. Okay, so these events are independent. The probability of one has no effect on the probability of the other. And then number 9, a fair die is rolled. The probability of rolling a 4 is 1 over 6. The probability of rolling an odd number, so I'll do odd, is 1 over 2. Explain how you know that these two events are mutually exclusive. 4 is even. That's it. You can't roll a 4 and roll an odd number at the same time. Okay? So you can't roll a 4 and an odd at the same time because 4 is not odd. That's it. Number 10 is there's really not word problem-y at all. So, if the probability of A is 0.28 and the probability of B is 0.31, and it's known that the events are mutually exclusive, this means that the probability of A and B is equal to 0. They can't happen together. What is the probability of one or the other? So here we would do the probability of A or B. We have this formula is equal to the probability of A plus the probability of B minus the probability of both. So here this is equal to 0.28 plus 0.31 minus 0. So the probability of A or B is 0.59. While experimenting in her calculator, Jordan creates this sequence here. Write a recursive formula for this sequence. So recursive, this means I need A sub n minus 1. Okay, so here, the way that this is going, so here, this is actually a more difficult one because what's happening here is not arithmetic or geometric. So you have to see if you can figure out a pattern. So here, to get from 4 to 9, you would do 2 times 4 plus 1. That gives me 9. So I have to see if that works. So now we would do 2 times 9 plus 1 to give me 19. 2 times 19 plus 1 is going to give me 39. And then 2 times 39 plus 1 gives me 79. So that is the pattern. So what's happening here is A sub n is equal to 2 times A sub n minus 1 plus 1. Okay, so determine the 8th term in the sequence. So you actually have to go through and do this a whole bunch. So I'm going to erase this piece over here just so I have more room. So I have 1, 2, 3, I have 5, so I need A sub 6 is 2 times 79 plus 1, which gives me 159. A sub 7 is 2 times 159 plus 1 is 319. And then my last one, A sub 8, this is the 8th term, is 2 times 319 plus 1, which is 639. So this is your 8th term. Number 12, consider the following sequence. Here you go from 10 to 2 to negative 6. This one's a little bit easier because here, this is arithmetic. Each time, you are subtracting 8, so you are adding negative 8. So write a recursive formula. That's super easy. A sub 1 we know is 10. So A sub n for my recursive formula is equal to negative 8 plus A sub n minus 1. Or you could say A sub n minus 1 minus 8. Whatever way you want, it's fine. It's the same thing. And then explicit formula, you need a definition. Okay, so for this one, it's actually on your reference sheet. So you have A sub n is equal to A sub 1 plus, in parentheses, n minus 1 times d. So here, A sub n is equal to 10 plus n minus 1 times negative 8. So A sub n, if you clean everything up, you should get, this becomes positive 8, 18 minus 8n. This is your explicit. So explain which you would use to find the 89th term. I would use explicit for this. Okay, the reason being that I don't want to sit here and find 88 terms that came before it. So just use the explicit definition for this. So now find the 89th term. So I would do A sub 89, and I would plug in 89 for n. So 18 minus 8 times 89 tells me that A sub 89 is equal to negative 694. Number 13, consider the following sequence: 3, -12, 48, -192. So this obviously is not going to be arithmetic because you're not adding the same amount each time. So here, this is actually going to be, this is geometric. Okay, so in this case, I am multiplying by -4 each time. So write a recursive formula. So my recursive formula here, I know that a sub 1 is equal to 3, right? I have to write that because I have to know where I'm starting. And then a sub n is equal to -4 times a sub n minus 1. For the explicit formula, again, explicit formula of geometric sequence, that's on your reference sheet. That is a sub n is equal to a sub 1 times r, this equals r raised to the n minus 1. So here, a sub n is equal to a sub 1 is 3 times -4 raised to the n minus 1. So to figure out the 9th term, I'm going to use this formula and I'm going to plug in 9 for n. So a sub 9 is equal to 3 times -4 raised to the 9 minus 1. So I can type that whole thing right into my calculator. And I get that a sub 9 is equal to 196,608. 14. In a theater, there are 16 seats in the first row, and every row after that increases its seat number by 2. So this tells me I'm increasing each time. So my recursive formula, a sub n, first, a sub 1 is 16, because that's how many are in the first row. And here you're increasing it by 2. So you have a sub n minus 1 plus 2. That's recursive. Explicit, that's your formula. A sub n is equal to a sub 1 plus, in parentheses, n minus 1 times d. So a sub n is equal to, my first term is 16 plus n minus 1 times 2. So my cleaned up explicit formula is 2n minus 2, so this is 14 plus 2n, or 2n plus 14. So for this part, determine how many seats are in the 15th row. I would do a sub 15 is equal to 14 plus 2 times n is 15. So this here is 30 plus 14 is 44 seats in the 15th row. Number 15. In a theater, there are 10 seats in the first row, and every row after that has 4 more seats than the row before it. So this is similar to the one that we just done. If there are 22 rows of seats in the theater, how many total seats does the theater contain? So here, this tells me I need to do a series for an arithmetic. So series for arithmetic, that means that I'm adding all of them up, because I'm not just finding how many are in a specific row. I'm finding how many are in the theater total. So here I would need to do s sub 22. Okay. Before we do that, why don't we talk about what the actual formula is? This formula, because this is arithmetic, this is not on your reference sheet. You need to know this formula. This is s sub n is equal to n times the first term, a sub 1, plus the last term is a sub n divided by 2. Okay, so here I have that s sub 22, right, because I'm looking for 22 rows, is equal to n, we just said is 22, a sub 1, we have 10 seats in the first row, plus, I need to figure out what is a sub 22. I need to know how many seats are in the last row, and divide it by 2. Okay, so a sub n I'm actually going to do over here. A sub 22 is equal to, we have the first term plus n minus 1 times d. I'm increasing by 4 seats each time. So this is equal to 10 plus 21 times 4, which is 94 seats in the last row. So 94, I'm going to bring and put into this formula over here. Here this is equal to 1144 total seats. 16. Nathaniel wants to increase his swimming endurance. On the first day, he plans to swim 6 laps. And then every day after that, increase his lap count by 10%. Okay, So here, if you're increasing the lap count by 10%, I have to take what I already have. I have to take 100% of what I have and add 10% to that. Okay, so in this case, this is going to be R is equal to 1.10. You're taking 100% of what you have and adding 10% to it. So write a recursive and explicit formula that can be used to determine on any given day. So on his first day, this is 6 laps. So recursive, your recursive formula is going to be a sub n is equal to, you're multiplying it by 1.10, so this is 1.10 times a sub n minus 1. And then explicit, a sub n is equal to, a sub 1 is 6 times 1.10 raised to the n minus 1. The reason why you have n minus 1 is because this here is a sub 1, not a sub 0. He's doing 6 laps on the first day. (17) similar. So here she's increasing the number of pages that she reads at night before falling asleep. So on the first night she's going to read 2. On the second night she's going to read 4. Third is 8. So then fourth would be 16. So here you're multiplying by 2 each time. So this is geometric. So if her novel is 250 pages, will Lauren finish her novel in 1 week? So I need to figure out how many pages she reads in a week. So I need to figure out a series for 7 for 1 week. For geometric, this is the formula that's given to you on your reference sheet. S sub n is equal to a sub 1 minus a sub 1 times r raised to the power of n divided by 1 minus r. So here a sub 1 is 2 minus 2 times r is also 2 raised to the power of 7 divided by 1 minus 2. So you can do alpha y equals to get a nice clean fraction if you want. So you have 2 minus 2 times 2 raised to the 7th divided by 1 minus 2. And this is equal to 254. So she reads 254 pages in a week. So if her novel is 250 pages, will she finish her novel? Yes, she will. All right. And then we just have our review questions left. So write the equation of the curve that's equidistant to the point and the line. This is your equation for a parabola. So this is x minus h squared equals 4p y minus k. This is not the vertex. That is the focus. This is the directrix. So draw it out. So I'm going to do this over here. So we have the line y equals negative 2. And then we have 4, 8. So we have 1, 2, 3, 4. We're going to come up here. So this is my point. Okay, so this is the focus. This is the directrix. I need to figure out what point is in between them so I can count. The distance between here to here, the whole thing, is 10. Right? So I'm going to go 5 up, 5 down. So that actually puts me at 4, 3 for my vertex. So my vertex is 4, 3. And now I need to figure out the p-value. So this is a positive parabola because remember, your focus has to be inside the parabola. You can't go past the directrix when you're drawing it. So this is positive. And then the distance from here to here, right, from vertex to focus, is a positive 5, so that is my p-value. So when I plug all of this in, I have x minus 4 squared is equal to 20 times y minus 3. And that's it. That's your equation. Number 19. Johnny invests $5,200 into a savings account with a fixed annual interest rate of 1.8% compounded quarterly. This is my formula that I'm using. I still need to know these formulas. P times 1 plus the rate divided by n raised to the nt. So he's investing, I'm going to do 19 down here, and then I'll do 20 over here. So here, how long will it take for him to obtain $8,000? That's equal to his initial is $5,200 times 1 plus the rate is 1.8, so this becomes 0.018, divided by compounded quarterly is 4 times a year, raised to the 4t. So I would do 8,000 divided by 5,200. I'm going to write out a few decimals, but I keep that number in my calculator. 1.53846 equals. I'm going to clean this up in here too. So this is 1 plus 0.018 divided by 4. This is 1.0045 raised to the 4t. So now I have logs. Log of this is equal to 4t times the log of this. So I divide by the log of 1.0045. And I get 95.94476 is equal to 4t. So t, this is rounded to the nearest 10. So in my calculator, I divide by 4 and I round. So this is 23.98, which becomes 24.0 years. Okay, number 20. You decide to invest $600 into an account. How much money will be in your account? So here, this says compounded continuously. So my formula is A equals PERT. So I'm looking for how much money will be in your savings account. So I'm looking for A. I'm given that P is 600. E, the rate is 0.023. And the time, this says after 3 years. So I can do that whole thing in my calculator without having to do any logs. So here, you will have $642.86. And that is it. Have a good day.